So a machine of mass 500 kilogram. Okay, wait. Okay, machine of 500 kilogram. The mass is given here, 500 kilogram. And then the length is 2 meter. Having a rectangular cross section with a depth of 0.1 meter. And the width is the 1.2 meter. And also given here the Young's modulus E, 2.06 times 10 to the power of 11 Newton per meter square. All right, so these are the values given in this question. All right, so let's try and calculate this. The question now asks you to reduce the vertical deflection. Right, so we know that in vibration, the deflection symbol is delta, right? So they ask you to reduce the vertical deflection of the beam. Okay, this is the beam here. A spring of stiffness K is attached at midspan as shown in figure below. Determine the value of K needed to reduce the deflection of the beam by 25% of its original value. So they ask us to find the value of K, the spring attached here. What is the value of K needed if we want to reduce the deflection of this beam? Okay, if you want to reduce the deflection of this beam by the first question, 25% of its original value. So anyhow, before we want to find the answer for question for A, B, and C, 25%, 50%, and also 75%, we have to find the original value of the beam's deflection. All right, so you want to find this beam's deflection first. Okay, so first of all, before we're going to find the beam's deflection, the beam's original deflection, what are we going to find first? Okay, first of all, you have to know the stiffness formula of a simply supported beam with the load at the middle. Okay, you can actually find this equation in the textbook. It is actually at the very early pages of the textbooks. So I'm just going to write it down here. First, a simply supported beam with the load at the middle. The formula will be, okay, remember you can find this formula inside the textbook, yeah? So the formula is K, the equivalent stiffness will be 48 times the Young's modulus and times the moment of inertia divided by with the length cube. So this is the formula, all right? Okay, this is the formula for a simply supported beam with a load at the middle. The stiffness formula, all right? So now, why do we have to find the K? Okay, because we want to find the beam's original deflection. Okay, as we all know, the formula for deflection is actually the force divided with the stiffness, right? So deflection, the formula of a deflection is force divided with the stiffness. So the force of a beam with a mass at the middle will be mg, right? Force equals to mg over the K. We know the m, we know the mass, we know the g, 9.81, but we don't know the K. All right, so that's why we want to find the K first using this formula. All right, so now we're going to find the K, but inside this K formula, we don't know the I. So we have to find the I first. So in order for us to find the I for a beam, the formula of I for a beam is 1/12 times the width times the depth to the power of 3. Okay. So this is the I formula for a beam. So we're going to substitute all the values now. So I equals to 1/12 times the width. The width is 1/2, right? This is the width 1/2 and the depth is 0.1. So the width is 1.2 and the depth is 0.1 to the power of 3. So for this, you'll get the
Sorry,
answer.
Carol.
Yes?
Carol, there's something
Yes.
on the screen.
Oh yeah, sorry, I didn't realize that. Okay. I'm using a free trial, so it keeps on coming up. So, okay. So once you substitute the value of the width and also the value of the depth, so you'll get your I value to 0.0001 meter to the power 4. All right. Once you have the value for I, you can substitute back inside this stiffness formula, and then you get your answer for the stiffness. Okay. So this is the answer for this one. Next, substitute your answer inside the formula. Okay, remember, let's say for the stiffness of the spring, the question already gave us the notation as the K. So I'm going to assume the stiffness for the beam is K1. All right. So I'm going to find the stiffness for the beam, which I've already defined as K1. So just use this formula up here. All right. So K equals to 48 times the Young's modulus. Young's modulus for this question is 2.06 times 10 to the power of 11. All right. So times 2.06 times 10 to the power of 11, and then multiply with the I. Right. Find the I. We've already have the I here, 0.0001 over with the length to the power of 3. Okay, so the length is 2 meter, right? The length is 2 meter. So 2 to the power of 3. Okay, so once you substitute everything, then you can just calculate the value for the stiffness for the beam. It will be 1.2 4 times 10 to the power of 8 Newton per meter. All right. So now we've already have the value for K, the stiffness value for the beam. Okay, now proceed to find the original deflection of the beam. All right, the third step now, find the original deflection. For the beam. Okay, so we know that the formula for deflection is delta equals to F over K, where your F, the force is equals to mg, right? So basically mg over K. Okay, we're gonna find the deflection for the beam. So the K now is K1 because I've already identified that the K1 is the stiffness for the beam. All right. Next, just substitute all the values that you have. So the M for this question, the mass given in this question is 500 kg. So 500 times the G is 9.81 divided with the K that we've already have just now. We just got it just now, 1.24 times 10 to the power of 8. So the deflection value for this will be, let's say I put it as deflection 1. 1 refers to the beam. So the original deflection value of the beam will be, if you calculate this, you'll get your answer to be 3.96 times 10 to the power of negative 5 meter. Okay. So this is the value for the deflection of the beam, the original deflection. All right. So next, only then we can answer the question that the question A, B, and C here. First of all, 25% of its original value. So we've already have the original value, original deflection value of the beam, which is 3.96 times 10 to the power negative 5. Okay, so if the question wants us to find the value of K, all right, which is 25% of the original value, So we have to know that the springs here, the stiffness here is arranged in parallel. Okay, because they are on top of each other, so it's basically a parallel configuration. So we know that the formula for K, okay, springs in parallel, okay, is, for this question, we have the stiffness for the beam, which is K1, and the stiffness for the spring is K. So remember, in parallel, stiffness the K will plus with each other. So this is the equivalent K for this question. Okay, now, only then we can find what the question wants. So for the first question, A, 25% of the original deflection. So 25% is actually 0.25, right? So 0.25 of the original deflection, which is delta 1, the one that we found just now. So 0.25 of the original deflection. So just use this back, all right? So 0.25 of this, right? So 0.25 of the original deflection. Remember, the formula and everything remains the same, but now the formula is mg over equivalent K, right? Because they've already add the new spring under the mass. Okay, so the equivalent K will be this one, K1 plus K. The one that we want to find now is K. All right, so we already have the K1. So basically just use this back. You just have to add K over here. Okay. So 0.25 times the original deflection, use this, 3.96 times 10 to the power of -5 equals to m, which is 500 times the g, 9.81 over K1, 1.24 times 10 to the power of 8, plus with the K that we want to find. Okay, so if 25% of the original deflection of the beam, the K, if you calculate it, you'll get the K to be 3.71 times 10 to the power of 8 Newton per meter. All right. So basically you can do the same thing, just change the 0.25, sorry, you can just change the 0.25 into 50% and also 75%. All right. So I'm going to let you guys try to calculate what's the value, what's the answer for B and C first. Okay, so if you do the same method for B, which is the for B, they want us to find 50% of the original deflection. So you can just change it over here. 50% equals to 0.5, right? Of the original deflection. So just change all the value here to 0.5 instead. Okay, everything, the value for original deflection, mg, and also K1, everything remains the same. We just want to find K. All right. So for this question here, if you change everything to 0.5 instead of 0.25 just now, so you'll get the new value for your K is 1.24 times 10 to the power of 8. All right. Again, do the same thing for C. Okay, now for C, the question wants you to find 75% of its original value. All right. So 75% of its original value. So just change from 0.5 to 0.75. 75%, right? So 75% of the original value. So just change everything inside here to 0.75, 0.75. And then you can again calculate for K, the value for the spring. And the value for the spring, the K value for the spring, you get the answer to be 4.12 times 10 to the power of 7 Newton per meter. Okay, and that's how you guys can get the value for K at different percentage of the original deflection value. All right, and that's how you do it for question 1.11.